Okay, so here are the rays for the convex mirror. So the first thing I want you to do is to just copy down these notes for the parallel ray, the radial ray, and the focal ray. Okay? Parallel ray, the incident ray is parallel to the optical axis, very similar to our concave mirror. It hits the mirror and it reflects as if it's coming from the focal point. Okay? The focal point on a convex mirror is on the other side of the mirror. The radial ray is very similar to before. It's going to move as if it's going to pass through the center point. Remember, focal point for a convex mirror is on the other side. So it's going to move as if it's going to pass through this point. It's going to hit the mirror and it's going to reflect off that same direction. And then the third ray is kind of the opposite of the parallel ray, the focal ray. The incident ray is going to be directed as if it's going to pass through this focal point, but when it hits the mirror, it's going to reflect parallel to the optical axis. Okay? So if you need to pause the video to go back and write all these things, make sure you write all these things down, and then I'm going to go through and actually model them. Okay, so for this first ray, the parallel ray, we're told that it is parallel to the optical axis, so I'm going to draw that here. You should as well. So it's going to be parallel to the optical axis. It's going to hit the mirror, and it's going to reflect as if it's coming from this focal point. So I'm going to line up, and I'm just going to draw like a dashed line so you kind of see. So it's coming off of this point and then it reflects, oh, I should use my ruler. It's going to reflect along that direction. Okay? So that's the parallel ray. The next ray is the radial ray. Marker trouble. The radial ray. And this one is directed as if it's going to pass through this center point, this 2F point. So I'm going to line it up with that point. Okay, so you can kind of see it's lined up as if it's going to pass that point, and it's going to reflect back along that same direction. Okay, the third ray is this focal ray. The incident ray is directed towards the focal point. So I'm going to direct my ray towards this point right here. Okay, so I'm going to line up my ruler. So you can see I've lined it up with that point, but when it hits the mirror, it's actually going to reflect parallel. So you can see for my parallel ray, it goes off in that direction. For my radial ray, it actually goes off in that direction. And for my focal ray, it goes off in that direction. So something to note is that these will not intersect, okay? So the rays do not intersect on the object side. Convex mirrors do not give you real images. They're always going to give you distorted and blurry images. But mathematically, they could intersect. They could intersect behind the mirror. Like if we were to project our rays backwards, and actually our parallel rays are reflected or projected backwards, our radial rays projected backwards, but if we projected backwards this one right here, right here, right at that point, I will actually see this point of intersection, and this point of intersection, so the intersection point is behind the mirror. And what what that means is it's considered a virtual image. So a virtual image is where we get a mathematical or we get a graphical solution to something that's not really possible. Like there will never actually be an image behind the mirror. But mathematically, if we were to solve it, we'd get an answer. And this answer actually translates out to be like a negative image distance, okay? So mathematically, when we work with convex mirrors, our DI value is going to be a negative value, and that indicates it is a virtual image. So this should kind of summarize the ray drawings for convex mirrors.